So we're going to look at inverse functions. So this function here is a quadratic. And the inverse function is something that kind of works like this. If I have a quadratic like this, the graph of it would be flipped on a 45-degree line, like a slope of 1, and it would kind of look like this. This is what the inverse of that function is going to be. But we want to find it algebraically and then kind of graph the two of them. So the best way to do this is, instead of writing f at x, though it's used to a function, we're going to replace f at x with y. Okay? So y is equal to negative 3x plus 2 squared minus 5. And the reason I'm writing it as y instead of f at x is just it's going to be confusing the next step if I leave it as f at x. And the next step here is to actually interchange the y and the x, their positions. So I'm now going to switch this, so now it's x is equal to negative 3 y plus 2 squared minus 5. And now the goal is to once again isolate for y. So I got to move everything to the other side of the equation. So the very first thing to do is move negative 5. When I move that over, I'd have x plus 5 is equal to negative 3y plus 2 squared. And then I want to move my negative 3. Well, because it's multiplication, when I move it to the other side, this becomes divided by negative 3. So we have x plus 5 over negative 3, and I can separate them each, or I can just leave it all over negative 3, is equal to y plus 2 squared. Okay. I need to now move the power. The opposite of the power of 2 would be the root of 2, so I find the root of this. So the next line reads square root of x plus 5 over negative 3 is equal to y plus 2. I've now gotten rid of this. These essentially cancel out or create a 1. And then the final step is to move that 2. So we have a root of x plus 5 divided by negative 3 minus 2 is equal to y. And to make this look a little more like transforming an equation, it would be like this. The k value here is actually, if you common factored out 1 over negative 3, it would be like that. 1 over negative 3,
yeah,
x plus 5. Yeah. And then outside of the function is negative 2. So assuming this is correct, we're going to write our two functions in. First one we had was negative 3x, I think I said plus 2 squared minus 5. So here's the original. And what should happen now is we should flip on a line of y equals x. So I'm going to make this a dotted line. So the inverse of this would flip on this line. Okay. So our inverse was root negative 1 over 3 bracket x plus 5 minus 2. And you'll notice, in order for this thing to be a function, let's see if I can get this.
It won't even add the bottom?
Yeah, it doesn't add the bottom, mainly because, there we go, if I were to add the bottom of this, that's not right. So you can tell this is kind of flipped on there, right? It's been on a 45-degree angle. It looks about right. But in order to pass the vertical line test, you can only cross a function once. And because this program only draws functions, it doesn't draw the bottom of that. There you go. So it only will draw the top. Technically, the bottom would have been correct too, but they usually draw the positive value of it. But this would be the inverse of that function. Okay. So